Awesome. I think we can start, right? Welcome to our session, the Unravel the User Experience puzzle. So before we start, let's first do the introduction. If I
you don't want to explain to them why you chose this title? I mean, I came for you. So Ryan recently took up a new hobby.
Puzzling.
Puzzling. And
lovely.
He's getting better, right? He's now up to puzzles with more than 4 pieces. So.
Yep. Thank you. Thank you. So let's first start with a short introduction. My name is Ververs Bijerk. I'm an independent technologist based from the Netherlands. I help large customers, primarily in the financial sector, help automate a lot of stuff. So I do a lot with DevOps, especially currently with AVD. Active within the community, I like to collect stickers, as you can see. So that's about me.
Oh, nice one. Nice to meet you.
Nice to meet you. Yeah.
Oh, this is where I have to.
Yeah. Yes, it's like your cue.
I thought you were going to do that.
You're better at cues.
So, hello, everyone. My name is Eljto from Gulik. I'm also Dutch. I recently joined Citrix in the product team. I'm the principal product manager, as I say, for HCX Graphics Siemens, and I also recently took up the app experience domain. And I don't have that much stickers anymore.
You have to turn them in when you joined the dark side.
When I joined the dark side, for sure, yeah.
So Eljto already explained, I got a new hobby, which is puzzling. I'm not good at puzzling. 4 pieces, and it's like my level. No, but for this session, what's important, we want to give you a little bit of insights, the complexity of user experience. So this session is all about the user experience. So we're going to go deep into a lot of examples, and hopefully at the end of the session you will have a better understanding also how to quantify it. So that's actually the entire goal of the session. But first I want to have a quick word about Go EUC. So who already knows Go EUC? A couple, okay. So Go EUC is our community platform, which is actually a non-profit platform which we started in 2017 already. And our primary goal is basically exploring technology. So doing new research is creating new knowledge. And this is helpful for us also in our daily work. We like technology and exploring this technology, and I can use it to help my customers. But Eljto can also use that for his product that he's primarily responsible for nowadays. So this is basically also our mission statement. So we want to use this, this knowledge also to inspire other people. This is the reason why we're here today, presenting the insights we have regarding user experience. But we're not just doing this for user experience. We have a lot of researches that we also publish. So this is the entire goal of Go EUC. In order to run Go EUC, we have one primary sponsor, which is Logen. And Logen helped us from the beginning of the, when we started the non-profit foundation, by also sponsoring the platform. Because running a platform like this, it costs a lot of time and effort, but also money. We burn a lot of resources, especially when using cloud resources. It goes very, very hard.
Cloud resources with GPUs.
Yeah, lovely.
That'll drain your money very fast.
It will like burn the money away. No, but we're very happy with Logen, which is also one of the primary solutions we use for generating load on our platforms. So if you have any time after the session, of course, please take a look at Logen. It will also help them out. So besides the sessions we give at events like this over the world, we also publish the content on our website. So if you go to www.go-euc.com, you can actually read all the articles and researches that we give or did. And there's a lot of interesting topics here. So if you have the time, just go to the website. There's no registration required. It's just an open blog platform where you can just consume basically the articles and the researches. And I think this is your cue.
This is my cue.
Oh, I thought you were going to just stand there.
Oh, no, this is going to be easier. I like to walk around as well, just like you. So when we talk about user experience, it's good to start with a general definition of what user experience is. And the definition I found was... Thank you so much. The definition I found in the dictionary is a very generic one, right? The overall user experience is the experience that a person has when using a product, such like a website or a server or an application, and then especially in terms of how easy or how pleasing it is to use. Now, that's the definition, but that doesn't really help us much, right? What is user experience? And I tried to think of an analogy, and I've got one here. So these are two cars. One's mine and one's Ryan's. I'll let you decide which one's which. And while they are the same things, right? They have a steering wheel, they have a gas pedal to make it go faster, and they have a pedal that would usually stop the car, right? The user experience of these cars are pretty different. One, in my opinion, is easier to use because it uses analog dials, which is much easier. The other one is much more complicated. There are all kinds of buttons, screens, what have you. So the user experience in these two cars is very different. I like the old school car.
Because of your age, probably.
Probably because of my age, yeah. And Ryan's more akin to the new one. So that's a difference in user experience, but they do the same thing. And we all know that user experience, especially in IT, can go from right to left in a matter of seconds. But it's also very time dependent. Let's say that I would ask you, if you come into the office on Monday morning, you've been through Liverpool traffic, and I've heard that Liverpool traffic is horrendous in the mornings, right? It's raining, just like in the Netherlands all the time. You're soaking wet. You get to the office, you need to log on, you forgot your laptop, you use a thin client, which is maybe not the best one. You log on, it takes half a minute or maybe a minute, and I ask you, hey, what's your user experience like? And you would say, oh, well, it sucks. On the other hand, what if I ask you the same question when you just come back from vacation? You had a nice vacation, Bahamas or wherever you want to go. Sun is shining, you're on time. I ask you, hey, how was your login experience? It's same time, still 30 seconds. I ask you, how was your login experience? You're probably going to say, oh, pretty okay, right? I'm feeling peachy. So it's also dependent on the context that we're talking about. So that's not really helping us much to determine what user experience is and how we can measure it. We need a way to quantify it. We need to put a number to user experience because that's something that helps. That's something that you can compare quantitatively. Now, normally how you do that is you have an experiment, right? With a control group, you ask the same question to 100 people, 20 people in the control group. You do that in a testing environment over a large period of time, and you get some measurements. But that takes a lot of time. Really a lot of time, a lot of money. Not everyone wants to do that. So in our context, we defined 3 key metrics that we think will be most important to determine what user experience is and how you can measure it in the context of EUC. We have latency, we have audio quality, and we have video quality, or image quality, if you will. And these 3 metrics is what we define as our base metrics for user experience for EUC in this context. And then it's your turn again.
Yeah, let's start with the first one, which is the... no, I will just
you want to walk around?
Here. No, you can
sure?
just tap dance over there.
Oh.
There's no problem. No, so let's first start with latency, the first one. So if you ask an AI model what latency is, this is basically the answer you will get. But it's the time delay transmitted from the one point to another point. So in the context of EUC, and especially with cloud, you have the globe. So we're currently located not on the green dot, but that's where my home is located, which is based in the Netherlands. But if you go to a data center location which is located in, I think it's Ireland, right? I have to say it correctly. Let's say Ireland. The time or the distance between that will influence the latency itself. So in this case, we have quite high-speed internet connectivity in Europe. So that's probably okay, acceptable in regarding for latency. But the further you go away, the more physical distance is between your physical point and the data center. So the input or the latency in general will increase. This is something you cannot solve. It's just there. You have to accept it. So therefore, it's always important at least to select a location which is also near the users itself. So we're fortunate in the Netherlands. We have high-speed connectivity.
And tulips.
tulips, but we also have a lot of data centers. So I think primarily like Google, AWS, but also Microsoft Azure is located in the Netherlands. They say Amsterdam, but it's actually not Amsterdam, it's more up to the north. But yeah, the connectivity, at least to the Amsterdam or the West Europe regions, are very, very low. So in order to actually measure that, there are tools out there. So this is one of the examples. This is just a public website. You can actually select all the regions in Azure, and from your endpoint, you can actually measure what the latency is towards the locations or the regions you have selected. As you can see, it's a little bit like influence also with the behavior of your internet connectivity or the stability. But this is a nice way at least to see what's the best location for you at least to host the resources. So in case of a company, if you have your primary users located in Amsterdam or in Utrecht or somewhere in the Netherlands, then you have to select the proper location, which is going to be West Europe in this case. So another factor you have to take into account is that the latency is also really workload dependent. So if you look at, for example, like browsing the web, a higher latency is actually very acceptable because you're just primarily consuming text. It can be like a video, but the video can load. It doesn't matter if the latency is very high. If you go to the context of gaming, latency is way more important. You want to have a fast, stable connection, making sure you, a little bit depending on what kind of game you play, but in the multiplayer context, you want to make sure it's consistent. And with a higher latency, you probably will miss some frags in this case. But also in like communication using with Teams, what Lee also showed, it's also important to have like a consistent latency. Otherwise, you will see somebody talk, but it's not in sync, which can be annoying. And you've probably all experienced like that somebody trying to start a sentence, but there's a latency on the line, so we'll just start together.
Yeah.
Which is annoying.
Yep.
But in the financial sector, if you look at trading, then latency is like really, really important, which can also make millions. So therefore, the latency is like 0.001 millisecond. That's the norm for trading and financial sectors. So it's really important at least to have a clear understanding of latency and the workload. So if you look also at latency in a VDI scenario, you also have to take into account like the input latency itself. So there's a lot of steps that are required to actually do your activity. So in this case, an example is a mouse activity. That mouse activity needs to be processed by the endpoint system itself. It's going to be a render queue involved, there's display. In this case, in a VDI scenario, there's internet involved, but also your remote endpoint or your remote VDI itself. So there's a lot of steps involved with interacting with a desktop, and that's also the complexity of VDI and remoting solutions. So we have a small example regarding input latency. This is also one of the researches I did like a couple years ago. And in this example, I used a racing game locally versus a remote session where I experienced actually input latency. So you will see my local PC, which is the game PC, and a Citrix session. And as you can see already in the steering input, like how the hands behave, it's a little bit more choppy on the Citrix session itself. And this has to do with remoting, of course. There's a VDI or a machine in Azure. I think it's an NV6 with an NVIDIA GPU. And I experienced in this case a lot of input latency, so I really had to adjust the way I play the game. And eventually it also, on the timing, the lap timings, it was around 2 seconds difference in lap times. And I can drive pretty consistent.
What was your lap time then? I
have no clue, to be honest.
You remember what circuit it was?
It was Zandvoort, the classic layout. The classic layout. So we actually have one experiment that we want to conduct here. So we're gonna showcase the true a latency experience.
Yep. And for that we need 2 volunteers. Anyone into gaming at all? Any gamers here?
No?
That's the last video game I played.
Yeah,
One player, what's the other one?
Nope. Yep. So seeing was last game that Lee ever played, the guy ever played? Oh, Jim. There you go.
Okay, so this is a classic, which is from the age of Eljto. So let's
Ish.
start. And you should be able to move with your thumb stick.
Boom, boom, boom.
And probably one has experienced a little bit of frustration in the activity.
Oh, one of you is just much better in this game than someone else, right?
Bad workman blames his tools.
Yeah.
So who in this case is on the right side? I think it's you.
Yeah.
And what you're experiencing at this point, it's...
Well,
Indeed.
there you go.
So actually in this simple example, we created like input latency. So there's a random delay when you interact with the Pong thingy, which is actually
Pedal.
causing
It's pedal.
the pedal,
Yeah.
which is causing you to miss it, basically. But it can be frustrating. And Jim is winning.
Oh, look at his face.
He's really competitive.
Yeah.
But let's continue. But this is a classic example of input latency where there's like a delay in the input, which cannot make a game unplayable. So let's...
So what we want to do is to have a way to measure the input latency. And there are a couple of ways to measure the input latency. And the first one that we're going to showcase is the simplest one. I mean, I think everyone here, even Guy, has a relatively modern smartphone, right? Or you still have your Nokia 30... Yeah, look, modern smartphone. Yeah. So modern smartphones nowadays have the ability to record high-speed quality videos. And to real high speed. I think you get an iPhone 15. I think it could go up to something like 960 FPS.
I have no clue, to be honest.
So what you can do there is, if you look at movement, this is a very quick example. Not sure if you press play. Yep. So you can capture with your phone what you're doing on screen, and you can see that everything you do is being slowed down tremendously. Now this is a sample that I did on my phone, my old phone, recorded in 480 FPS, and I just moved a window around. The window moving was smooth, but as you can see, if you dial it down to 480 FPS, you can see that there's a delay in there. And what you can do, you can then calculate the latency that it took for when you start moving the window and when you actually saw it moving. Now, that's the easiest, the simplest way. Well, the easiest way, not the simplest way.
I think the most frustrating thing of this approach is that it's really time consuming because you really have to count the individual frames for the latency itself. So you have to go frame by frame and basically detect when the motion is started. So there are smarter ways to measure this. So one of those tools is the Eljto tool from NVIDIA, which is the tool you're actually seeing here. It's a luminance sensor detection method, which is basically can simulate the input and also detect when the input is actually presented on the screen itself and measure that. The downside of this device is you cannot buy it.
Thanks, NVIDIA.
So if you reach out to NVIDIA, maybe they will give you a sample, but yeah, it's hard to get. I got one at home. I didn't bring it along. Usually we do it, but yeah, it's. I also have like an example how it's actually working. So in this case, it's a Counter-Strike demo. I also like shooting games. So here you can see I'm pressing the button. It will simulate like it's triggering the mouse. And on the right side, it will just actually measure what the latency is between my mouse input and what's happening actually on the screen.
Yeah, so this device does actually two things. It's a hardware device, and it simulates either a keyboard or a mouse. It presses a mouse or a keyboard switch, and then it also measures with the luminance sensor how long it takes before the action, in this case a muzzle flash, occurs. And that is your input latency.
So luckily there are other ways and other methods.
Yeah, it's actually pretty simple to build something like this yourself. You can do this by yourself with a microcontroller. This is one from Adafruit, QT an illuminance sensor, an RGB color sensor. And if you want to build it yourself, it actually costs you around maybe 12 to 15 euros for the microcontroller and for the luminance sensor. And this works pretty much exactly the same thing. You attach it to your monitor. And yes, I know my screen is very dirty.
Yeah, you have to clean it also.
And it does the same thing, right? It acts as a mouse or a keyboard. You simulate a key press, and you make sure that on screen you have something that the luminance sensor can measure. For example, green screen, mouse press, blue screen. And you can measure the time it takes between the color difference, the color variance, between those two slides. You can do it in PowerPoint, you can do it in whatever. It's very easy to use that as measurements to measure what the latency is, not only on your local PC, but it can also be used in a remoting scenario.
So actually the code, because you created this, Eljto, you also shared it on GitHub, and there's an article on Go EUC how to build this yourself, and where you can get all the hardware and just buy it from, I think it's Amazon? Yeah. So regarding researches, we have multiple researches where we actually use the Eljto device for measuring stuff. So in this case, this is just one of the examples, and we did the frequency hertz of the screen itself. So I have a gaming monitor with a high refresh rate, where I actually can set it from 60 to 120, but also to 144. I know there are faster screens out there nowadays. But you can really see that this is also one of the factors that affect the input latency itself. And yeah, you can measure it using an Eljto device or a device that Eljto just mentioned.
Or using the method with recording the screen.
Yeah. So let's go to the next one, which is audio. So again, if you ask an AI, this is basically the definition of audio. And what's important here is the audio is basically sound waves that you can hear with your ear. So if you, yeah, lovely, thank you.
Thank you for that insight. Yeah.
So it's outputted in hertz. So if you have slow vibrations, it's a lower pitch. If you have high vibration, it's a higher pitch. And the quantification is 1000 hertz tone is 1 cycle, 1 millisecond. So we got actually an example here, and this is going to be annoying because this is a measurement to see how, if you can still hear it, and which is age dependent, because this is also a factor regarding audio. So Guy, I'm sorry.
So yeah, you're going to hear test sound and you're going to change frequency. And probably somewhere along the frequency range, you're going to stop hearing it. For me, it's pretty quick because I'm old. But probably for some of you, the tone will take a lot longer to disappear.
So if you don't hear the tone anymore, can you then raise your hand, please? Here we go. Thank you. It will start. It's annoying.
No, it's nice in your voice.
Who's going to be the first one?
Oh, no, still it.
Ooh.
Yep.
I'm nearly
That's it for me.
You're lying, Lee. You're lying. You're way older. No, but as you can hear, this example, it's also age dependent. So the younger you are, the higher frequency you can hear. So this is eventually also affecting you in the hearing and the experience of audio itself. But there is also another thing, and we got another example here. Somebody knows which series this is? Mr. Robot, indeed. I really can recommend it. But it just sounds fine, right? There's nothing off with this example. To be honest, there actually is. There's a delay in the audio itself. So I just moved the audio track. I think it's like a half a second to a second. But this is, again, it's dependent on what you see.
Yep.
Because there is indeed, like Guy already does, there's no lip sync in here. It doesn't matter because it's a voiceover. So that's the reason you experience it like as okay. But there was one thing that you can actually notice is the switch between in the Metro subsystem, the audio kicks in a little bit later. But it doesn't affect the experience itself. I got another example.
What's wrong?
So as you can see in this example is
Here.
or here and see
With your ears.
with your ears, yeah. No, but we changed it a little bit. So it started in sync. I moved it off sync. You can see it with the lip synchronization. But as you also heard, what they do a lot in Germany, luckily not in the Netherlands, they voice over. So probably for a German speaking that's actually watching this, it doesn't affect him because he's used to the voiceovers. So there's always like a miss-sync in the lips. So again, this is also, audio is really difficult. And examples like this, you can see it has an effect, but it's also really region dependent and how people experience it. So, indeed, this is also one of the things that they use, especially in productions, but also I think sometimes even YouTubers use it. They use this device to make sure that there is like a sync moment. You can actually physically see when it's snapping, so you can sync up the audio. That's the primary reason why they use the devices like this, or just a clap, in order to make sure that the audio is in sync with the video itself. I think that was you, right?
That was probably me, yeah. So, we have here 2 audio samples.
Mike?
No, it's Eljto.
We're going to make you listen to 2 audio samples again. Now, this one isn't going to be as annoying as the last one, but listen very carefully, and afterwards, by raise of hands, tell me which one of these was of better quality, first or second sample. So can I have a show of hands? Which sample is the better sample in your opinion? All in favor of sample 1?
Ooh, only one hand?
Sample 2? There you go. That was pretty easy for most people, apart from Brandon, right? Yeah, your hearing aid is going off, right? It's all those fast cars, motor sounds that'll kill you. So it was very apparent to most people because the audio sample we played are very different. One is an uncompressed one, and the other one is I think it's a 32 kilobit MP3. So the quality is really, really low. The size of the media files also completely differs. So I think one is a couple of megabytes, and the other one is, I think, 0.1 kilobytes. So there's a very big difference in between them. So that was easy. But then another question. How much better was the first example than the second example we showed you? Well, that's a more difficult question, isn't it? How do you quantify that? Now, there are metrics for that. And one of the metrics we chose for that, to use for that, is called VSQL, and stands for Virtual Speech Quality Objective Listener. I don't know who came up with that acronym, but it probably was not a native English speaker. But that's part. Google co-developed that, and that's actually a way to quantify audio quality. It's a full reference method in which you feed it a high quality sample, and then you have a comparison sample that you feed it in, and it'll give you a score that determines how good the quality is of the audio sample. And there's a measurement there, it's called MOS, mean opinion score, and it has a score from 5 to 1. And the thing you have to remember is 5 is excellent, so a score of 5 will be an audio sample that is comparative in quality to the reference sample, and 1 is really, really bad. Which one is that here?
So this is research we did regarding Teams optimization, which we also presented, I think, a couple of years ago at London event.
Exactly, yeah.
So this shows the audio difference between an optimized and an unoptimized team session. where you can actually see that when there is no optimization applied, the audio quality degrades compared to the offloaded scenario. So there is an actual difference in there. And you can read all about it on Go EUC.
Yep. And
Lovely.
that brings us to our last topic, image or video quality. And small history lesson. Guy, you probably know what this is.
Is it a cloud?
It's a cloud, yes, exactly. This is, I also talked about it. This is actually photographic film that Kodak developed way back when they still exist. I don't think they exist anymore, Kodak. Do they still exist?
Yeah, they do,
But they don't make any photographic films anymore, right? This was a way to capture images way before we had mobile phones. And why am I presenting this? Well, if you look at movement and images, it's actually nothing more but a rapid succession of still images. And that was shown in the 1800s, I think it was 1878, by a horse in motion. And there was a scientist, and he said, hey, I can create movement from still images. And what he did is he took a couple of different images from a horse, a rider on a horse, and he played that in rapid succession on carnivals, fun fairs, whatever. And that gave the illusion of movement. There we go. Now, back in the time, people thought this was magic, witchcraft, because you take still images, you play them after, and it starts to become fluid motion. Now, in order this to become fluid motion, for your brain to interpret a rapid succession of still images into movement, you need at least 24 frames per second. Now, this is also the standard that we have now with MOV TV series and movies alike.
It's
24 FPS.
Actually, it is increasing. So you
Yep.
see a shift that it's switching towards 60 FPS, which will improve the quality of the videos, or
For
at
sure.
least the experience.
The movement, yeah.
Yeah.
Now, if you take the standard frame rate, 30 FPS, which is in most cases the default for most remoting protocol vendors. If you have 30 FPS, that means that each image is only visible for 33.3 milliseconds. Now, it doesn't sound much, does it? It isn't. Because if you take, for example, here, the 100 milliseconds, and this is the average time it takes for a human to blink. 100 milliseconds. So blink once, you miss 3 frames. And it gets even worse, because the average human blinks once every 5 seconds. And that basically means that we're blind 10% of the time. Now, fortunately, our brains are very good in filling in these blank spots, but 33.3 milliseconds is very fast.
Does it also take into account that you're sleeping?
No.
Oh, okay.
No,
Check.
when you're awake. Yep, thank you very much. So if you take a uncompressed 4K image, if you have to save it on disk, it roughly takes 25 megabytes. Now again, in today's standards, it doesn't seem much with all the gigabytes that we have in storage, right? But let's say you want to show that picture at 30 FPS. That means that 1 second you need 750 megabytes of data, bandwidth. Again, doesn't take that much, but this is every second. Let's go back to the 60 FPS that Ryan mentioned. That means that every second you need a throughput of 1.5 gigabyte. That's a lot, right? And we're all talking about the internet speeds in Western Europe. They're pretty good. We don't need compression because internet speeds are very good. 48. I looked up this morning on Wikipedia the list of fastest internet connection speeds in the world. 48 is the place that UK lands on. To put that into perspective, Tobago, the small island somewhere in the Atlantic Ocean, South Sea, is on place 13. Chile is on place 5. So no, guys, your internet speeds aren't that good. You need to make sure that you use your bandwidth efficiently. Now, fortunately, there are solutions for that. Video codecs. Who's heard of video codecs? Who uses video codecs? Okay. Yep. Video codecs. The word means decode, encode. Ooh.
Animations.
Nice animations.
Lovely.
At 30 FPS.
Wow.
There you go.
Codec.
So most of us usually use video codecs everywhere, right? When you watch Netflix, YouTube,
YouTube.
Thank you,
Yeah.
assistant. YouTube.
I'm missing my keys.
And even when you use remoting protocols, all remoting protocols, just like Citrix, use video codecs to make sure that we can reduce bandwidth of moving images. Thank you.
I'm going very fast.
You go very fast. We only have 8 minutes left.
I
So
have input latency.
yeah. And there are different video codecs out there, right? We have H.264, H.265, and AV1, just to name a couple of them.
So this is content that is not published yet. We're working on an article regarding the basically the encoders. So it's going to be published probably next week when I process all the feedback that I got. No, but we did a lot of feedback. No, we did an.
Microphone too close to the speaker if you get feedback.
Thank you, Guy. So we did an analysis regarding a video to actually quantify this and see what's the difference between the quality of the different codecs.
Now, it's not just about the quality, about the bandwidth savings that video codecs have, right? This is actually a picture of the Space Shuttle Discovery. It blew up. And does anyone know when that happened?
In the sky, indeed.
2003. That was the same year that we had the first SARS outbreak. MySpace was still there. And Ryan just graduated kindergarten.
Yep. No.
But my point here
A
was,
little bit older, Eljto.
2003 was when the world was introduced to H.264. It was a long time ago. And back then, we didn't have features like 4K monitors, 10-bit color, HDR. So it's not only about the fact that H.264 is an older video codec, but it doesn't have any support for these newer technologies. AV1 does. AV1 has better compression and better image quality over H.265 and H.264.
Does it?
It should. But it always comes with a downside, right? In IT, nothing comes for free. And in this case, because it's a newer video codec, it does better compression. It also means that you have to do more computational stuff to make sure that you can make that compression. And for that, you need a relatively modern GPU server-side to be able to do that. In this case, for NVIDIA, it's a NVIDIA Lovelace generation GPU. Or if you look at Intel, it's the Intel Data Flex Center 140, 170, or the Intel Arc Pros. To do that.
And AMD?
So AMD is a bit of a mixed bag. AMD doesn't have much hardware support in terms of AV1 in their current product lineup yet.
That's a bummer.
Yeah. Small history lesson. Does anyone know who this is? There you go. The hint was already in the last picture. This is Ada Lovelace, right? Ada Lovelace was actually the first computer programmer back in 1883.
I would say she invented the computer. Babbage invented a fucking calculator.
Exactly. She made sure that you couldn't only do simple calculations on the analytical machine. She could also mean you could have complex lines of code to do complex and multiple computations on the same machine. So she wasn't only the first programmer, she also invented the thing that Babbage said, hey, this is a calculator, and she made it into a computer. So small round of applause for Ada Lovelace. There you go. But back to video codecs. Now, how do video codecs work? Simply speaking, what they do is they don't send all image data, the 25 megabytes per 4K image, over the wire. What they do is they try to only save the changes in between those two images to make sure that you have a bandwidth reduction. And I asked ChatGPT, but how did they do that? And they gave me this answer. Discrete cosine transformation, entropy encoding, a lot of other stuff that I have no clue how it works. So, how do video codecs work? Basically by magic. So, I have two examples here. One is H.264 and one is AV1. This is H.264. Oh, by the way, does anyone know which car this is? Which one? California. Ferrari, California. I think it's a 4.2 liter V8. My dream car. But it doesn't really look that good with H.264. I rather like to see it with AV1. But does it play?
It doesn't play. Nope.
Oh, there we go.
Lovely.
Well, better even because I don't have any money for Ferrari, California, or any Ferrari, to be honest. Now, again, just with the audio quality, we need a way to make sure that we can quantify the image quality. We got 2 images here from a black sheep. I don't. Where is this from, actually? Do you know?
Yeah, it's a collaboration between Netflix and a Blender, and this is an open source project you can actually use. So they have all the material out there, and it's not copyright protected, so you can also use it. So therefore, we use this in the latest research.
We use 2 different image qualities here. Can you go back one? We still got 3 minutes, so much time. So these 2 have different qualities. But can anyone tell the difference between the left one and the right one? Which one is of better quality? It's hard, right? Because they're both not bad in terms of quality. And that makes it difficult to quantify which one's better. Now, we also found a metric to do that, and that's called SSCM. And SSCM is called structural similarity. And it uses algorithms to make sure that the quality comparison works the way our eyes and our brain does. So our eyes and our brain are very in tune to, to detect changes in color or changes in contrast, for example. If you look at the letters here, the white letters on the black background, we can very easily discern the 2 colors and change in contrast here. Now, SSCM takes that into contrast and tries to use that to give a perceived image quality score. And with that, we can quantify image quality. On the left one, on the right, 0.96. So the left one is of better quality. 1 is the highest, 0 is the lowest.
It's actually a nice example here, where you can see what's the difference.
Thank you so much for adding that slide.
So this is these are going to be the results that's not published yet, but here we actually tested the AV1 H265 and 264, and basically more towards the one is the best quality. And these are the conclusions. So I'm really interested also in the statement of Citrix, why they say AV1 is a better quality, Eljto.
That is a very good question.
Yeah.
I don't know yet. You haven't showed me the data yet.
Actually, I did, but...
No, it was old data.
Yeah. This is new data, though.
This is new data. So this is interesting, right? Here we can see that in our example, our frame of reference here, in terms of perceived image quality, H265 has a higher score than AV1. So we're not sure why that is yet. Because we said newer video codecs have better image quality, but apparently not in all cases.
Does it matter though, for something like Teams?
It all depends, right? There are cases, there are scenarios where it's very important. Yeah, Jim.
So, how good
We have 28 seconds.
How good an image codec doesn't necessarily mean how good an image it produces. It could be how good it is at surviving jitter or how low bandwidth it will cope with, right? Because it's all a balance between the compute and the bandwidth and the quality, right?
Exactly. So it depends, right? It depends on everything that's in between, but it also depends how important it is and what scenario you are. Probably if you are color grading something or you're in multimedia and entertainment, it's much more important than when you have a secretary doing office work. So it depends on your workload.
I think that's also one of the key takeaways.
Oh, yeah, there you go.
So just to wrap it up, it's important at least to have a clear understanding of the workload, because it's workload. Everything is workload dependent. You can tweak the protocol based on the workload, so you can add more or provide more FPS, for example, using also GPUs. And one of the things that I also experience at my customer is reducing the latency by selecting the correct data center. It's really important to make sure you select the right region for your users. I currently have people in my customer working from India in a machine that's located in Brazil, and they complain about user experience, which makes sense. So another thing is consider content redirection for improving the audio sync, because that can also help in terms of audio. But in the end, I think this is the most important quote that we live by. It is also one of the things at EUC we love. You just have to measure it, quantify, make a discussion at least at your customers way, way better. So therefore, we really recommend to actually collect the data and do the research before you go into a discussion, because an opinion is not really convincing. Can be, but for me it doesn't.
Nope.
So I got one shameless plug here. In November, I'm gonna run a marathon together with Lee. It's gonna be my first marathon. I'm running for a charity which is regarding mental health. So I think it's really important to also have good mental health. So if you're open, you can scan the QR code, which is a sponsoring page, to make a donation. That would be lovely. It will go directly towards the Mind Foundation, which is all regarding the mental health. So yeah, that would be lovely.
Thank you so much in advance.
Yeah, and I will leave this open so people can actually scan it. But that's it.
Well done, guys. Brilliant. That's really
Thank you.